We're recording. Today we're going to do day 2 of operations of functions. When you're done, you'll be able to add, subtract, multiply, and divide functions. And then we're also going to talk about composition of functions. That's when you make the output of one function becomes the input of another function. So there's just different ways of combining functions. We started this on Monday, and we talked about adding and subtracting functions. Now the difference between what we did on Monday and what we're going to do today is the degree of difficulty of these problems is a little bit more rigorous. Okay, so on Monday, what you did was something like this. If I gave you two functions, such as f of x is x plus 3, and g of x is x squared minus 4, and I asked you to add these two functions together, all you did was you took f of x, which is x plus 3, and added the g of x function. Now, they'll write it either way. They'll say f plus g of x, or they might just write f plus g. And all that means is to add the two functions together. So if you were to combine these two functions, what answer would you get? What's x squared, thank you.
Plus x.
Huh? Plus x? Minus 1. Good. It's in standard form. Nice answer. Now, I have a question for you. Let's talk about the domain. In chapter 3, if I were to ask you, what is the domain of this function? It's all real numbers, right? Any number can be added to 3, right? And if I asked you in chapter 3, what's the domain of x squared minus 4? It's all real numbers. Because any number can be squared and you can subtract 4 to it. So the domain of the compositions is the domain of both of them. You would have to figure out what's the domain of this, what's the domain of this, and where they overlap is the domain of the composition, or the sum of this, the new one. So on Monday, the domain was pretty basic because I think most of them were all real numbers. Okay, where then does the problem lie? Because I know the question that's always asked is, isn't it always real numbers? You guys always want to know the shortcut. What's the shortcut? Well, look at this problem. This is the sum. And now if I would have asked you what the difference is, what would you have done? You would have done x plus 3 minus x squared minus 4. And now what would you have done? Distribute the negative. And then you're going to be nice and rewrite it, right?
Yeah, I guess.
So, here is these are the two new answers. Now, if I asked you what is the domain of this, you'd say all real numbers, because you can square any number, add that number, and subtract 1. Same with this. So, how do you figure out the domain? It's the domain of both of these, the intersection of them. Well, where does all real numbers and where does all real numbers overlap?
On all real numbers.
It's all real numbers. Okay, now watch this problem. This is a PreCalc question.
Okay.
If they ask you what the rule is for adding or subtracting these two functions, f of x is named as square root of 9 minus x squared, and g of x is square root of x minus 2. Now, if I asked you to add these two up, what answer would you give me? What's this answer right here? I'm going to write it up here. F plus g is going to be
9
that's the answer. What would f minus g be?
root 9 minus x squared minus root x minus 2.
Okay. Now, there's nothing you can do to simplify those. It's just an ugly answer. Now they're asking you, what is the domain of these two answers now? Well, what you have to do is separately look at these. If I gave you the square root of 9 minus x squared, and we were in chapter 3, and you were taking a test on this, and I said, what is the domain of this? What did you learn that you can't have underneath a radical? You can't have a negative. So if you were to graph this, 9 minus x squared, this looks like this. This is a parabola. Now, do you remember, if you want this piece right here, 9 minus x squared, if you want it to be greater than or equal to 0, do you know what these two critical numbers are? -3 and 3. So can you tell me what x values would make this work? In other words, what's the domain of this? Where is my x values going to be greater than or equal to 0? We did these in chapter 2. Can you tell me what numbers, what interval is the domain? It's -3 to 3. That's the domain.
So we're writing them in interval notation.
Well, yeah, we're writing the domain of this piece in interval notation. Now, let's say in chapter 2, I gave you this problem. And I said, you had a test on this. If I said, hey, what's the domain of this? Well, what does this look like? This is a rocket, 2 units to the right. What numbers can you put in here to make this work? X minus 2 has to be greater than or equal to 0. So x has to be greater than or equal to 2. So would you all agree that the domain of this function is from 2, including 2, to infinity, right?
Yep.
Okay, so everyone's with me here.
So where do those?
So
intersect?
where, thank you, if you were adding these two functions or even subtracting them, what's the domain of the result?
Bracket 2, comma 3 bracket.
Very good. He got it. So the domain of the first one, and I'm going to draw a picture of it. This is the domain of that first piece right there. That's the f of x domain. The g of x was, where's 2 in relation to this? Somewhere here, right?
So where do they intersect?
So where do these two intersect?
Between 2 and 3.
Right here. This is the region. So what's the domain of the whole thing? We can only use the numbers between 2 and 3. So the domain is the intersection of these. Does everyone have that?
Yeah.
So the domain is, now why? Why are we restricting the domain to this answer?
Because it's all applicable to both.
Because I can't use, let's say if I wanted to put the number 1 in this problem. I can't put it in this one. It's undefined. So you're looking at the domain of both of them, the intersection. So if you read right here above, I'm sure you guys can read this on your own, but I'm going to read it with you. The domain of the sum and difference of any function is the set of all real numbers that are in both the domain of f and the domain of g. That's a g. I got cut off. Okay. So the same goes with products and divisions, quotients. Now, the thing with quotient is you want to make sure you don't have a 0 in the denominator. So you're going to do the same thing here. So what is f times g? You'd multiply these two. And what's f over g? This over that. And again, you're going to find the domain for both. Okay? Now let's flip over. What does this composition mean? It's just another way to combine functions. You're taking you're using you're inputting something into one function, and the output of that becomes the input of another function. That's what composition of functions is. Now, there's two ways to compose functions and write it. Here is one way, and here is another way to write this. F with an open circle, G. What this means is you're gonna take whatever's closest to this G in the middle, you're plugging, this is your input. You're inputting this into this function, and what you get, the output becomes the input of the F function. Does that make sense? Okay, so let's look at these examples. These are, you've already been exposed to this stuff. The difference between last year and Monday in this is they just get a little more difficult. The complexity of the rules is a little harder. You'll see that when we do these. Okay, so A. I read this. This is a composition. It says G of F of 2. Direct me what to do here.
Put 2 in F.
You're gonna put 2, input 2 into the F function. If I were to put 2 in here, here's the F function, what do you get?
9.
9.
2.
16.
3 what?
2 squared times 4. 16.
What?
1 is plus 1.
2 squared.
Oh,
Four.
yeah, okay, yes. What did you
Oh.
say, 9?
Oh,
How did you get
I don't
9?
know, I added by accident, I don't know why.
You're gonna plug 2 in here. 2 squared is 4. And then 4 times 4 is 16,
plus
and
one.
16 plus 1 is 17. So F of 2 is 17. That's the input is 2, the output becomes 17. Then what are you gonna do?
You take that output and put it for X and Y.
You're gonna plug the output is now gonna be the input of the G function. So what would you do with this?
1 over 17.
17 plus 2.
1 over 17 plus 2, which is
19, so 119.
1/19. Okay? Let's try B. What would you do here?
You're gonna input -1 in your G.
Okay, if you were to put -1 in here, what do you get? 1 over 1, which is 1. And then what are you gonna do?
Input 1 for X in your F function.
So if you were to plug 1 in here, what do you get? 5. The answer is 5. So F of G of -1 is equal to 5. Well, what if we said X? If you were to plug X into the F function, what do you get? You get 4x squared plus 1. So now you're gonna take, this is gonna be your output, now you're gonna plug that into the G function. So all this is gonna go right there. So you have 1 over
4x squared plus
4x squared plus 1 plus 2. Is there anything you could do to this problem?
Like terms plus 3.
You can add 1 and 2, you get 3. Questions? All right, how would you do D?
Same thing.
You're gonna take now X and plug it into the G function. If you plugged X in here, what do you get?
Stays the same.
Stays the same. So what are you gonna do with this now?
I'm gonna go 4 multiplied by 1 over x plus 2, and you're gonna square that 1 over x plus 2, and there you go.
And you don't have to worry about
Thank God.
multiplying that out. Okay, now, I wanna go to example 5. This is tricky. You are going to be given a function. This is named h of x. H of x is, the rule for this is the square root of 3x squared plus 1. Now, what they want you to do is turn h of x into a composition. You're gonna split this function into 2 different compositions, or 2 different functions. And I'm gonna use my marker here. So, underneath this radical, you have 3x squared plus 1. right? If I called, I'm gonna name g of x, or f of x, whatever letter you like, f of x is gonna be what's underneath here. So let f of x equal 3x squared plus 1. Everybody with me? Okay, and then I'm gonna go outside, and I'm gonna use my orange highlighter, and I'm gonna say g of x is the square root of something. Obviously, we use an x here. So we've got something underneath, and we've got something outside. So now, I'm gonna use f and g, and I'm gonna compose them. How do I compose them to get h of x? We're gonna do a couple of these and you'll get it. So h of x, tell me if you understand this. H of x, instead of using the rules here, I'm gonna say h of x is g of f of x. See if this makes sense. If I took f of x, which I named this, and plugged it into the g of x function, do you get that?
Yeah, so you're working backwards.
You're working backwards. So let's say I gave you, let's do another one together. Let's say I gave you h of x equals the absolute value of 3x squared plus 4x plus 5. Do you see two different functions? Do you see the inside? What do you want to call it? F of x. F of x, we're going to make this stuff, 3x squared plus 4x plus 5. And then I'm going to call g of x, what? The absolute value of x.
Where's that extra x going?
What extra x?
So you just made that new function, right?
Yeah, this is the absolute value of something. The absolute value of something. So now, I'm going to say h of x is g of f of x. I'm going to turn this, I'm going to plug this, according to what I have here, if I plug this in here and put that in for x, do I get h of x? Yes. Can you use the little o? Yes. And what would that look like if I used the o? There it is. So what if I gave you, here, let's do another one. What's f of x going to be? This piece right here. And what's g of x going to be called? 1 over something. And so what's h of x? Compose it with these two letters. Okay, now let's see, does this work? If I plug this, this in here, does it work? Yes. You get it?
I got us, yeah.
Yeah, you're just turning h of x, you're breaking this, we call this splitting. You're splitting this into two different functions, and then you're composing those two different functions to create the original. Oh, can they get it wrong? Oh, they could write h of x equals f of g of x. Is that wrong? If I took the g function and plugged it in here, I would be squaring that, and do I get this? No. So the way it's written is very important. Okay? Now, your homework is this back paper. Couple things I want to go over with you. Jump to number 17. Can someone explain to me what to do here? you're gonna plug 0 where? This says, I know it's hard to read, you guys, this comes from your book. So if you have your book at home, hopefully you can read this. I'm rewriting it. This is saying plug 0 in where? In F. Well, where is the F function? It's right here. If I plug 0 in here, what do you get? 1. Then what do? You plug 1 into the G function. What's 1 squared minus 1? 0. Now you're going to do this side. If I plug 0 in the G function, what do you get? 0. And then what's F of 0? 1. So what's your answer? 1. Okay, so does everyone understand those? Now flip to the other side, the back side. I want you to look, you don't have to do the domain of the composition ones, but can you look at the difference between on 25 and 27. Read the directions. It says, in exercises 25 to 28, even though you're doing 25 to 27, it says find the rule. The rule of FF. What does FF mean and F of F mean? What's the difference? So if I want to do FF, that's saying take x squared and multiply x squared. What do you get when you do x squared times x squared?
4.
X to the what?
4.
4. Now what does this mean? F of F.
Plug in.
You're going to take this, so this is what I like to do. I write it twice. Does anyone else do that? So what's f of x? It means take f of f. You're taking this function and you're plugging it in here. So it's an x squared squared. What's that answer? X to the 4. Okay? Now, 33, 35, and 37 are the splitting ones. So you might want to write splitting. Let's do one together. 33. Let's do this. So f of x is, I think it says cube root. I'm gonna go with cube root. It says cube root. So give me two different names. G and H. Good. Okay, split this up into 2. What are the 2 that you're gonna write? X squared plus 2. And then what's the outer part? Cube root of x. Good. So f of x is composed of did I write it right? I'm going to plug G. If I were to put this in here, do I get f of x? Yes. Do you get this? Okay. The last thing, the last 4 problems are really easy, but the way it's explained here is confusing, so I just want to start you off here. These 2 charts are given. These 2 are done. Does everyone see that? Now, they want you, 41, 42, 43, and 44 are your homework problems, but we're going to do one together. This is saying find g of f of x. G of f of x. So this is what they want you to do. They want you to plug 1 into the f function. So if you were to plug 1 into the f function, what comes out? 3. Then you're going to take 3 and plug it into the g function. If you were to plug 3 into the g function, what comes out? A 4. That's how they got 4. So now we're going to do 2. We're going to plug 2 into the f function. 2 into the f function, what do you get? 5. And then 5 goes into the g function, what do you get? So this answer is 2. You get it? Let's try this one. Let's see if we can get 5 here, and then we're on track here. 3 goes into the f function. 3 into the f function, you get 1. And then 1 into the g function, what do you get? 5. 4 into the f function, you get 2. 2 into the g function, you get 4. So this is 4. 5 into the f function, you get 3. 3 into the g function, you get 4. Think you guys got this? So for 42, you're gonna plug 1 into the g function first. So you gotta go to this one. 1 to the g function, you get 5. And then you're gonna plug 5 into the f function. 5 into the f function, what'd you get? What do you get? 3. So this answer would be 3. You get it?
Yeah.
Okay, this is your homework. You have about 25 minutes. Can you turn that video off, please? Thank you.